Alright, looks like we are live. So, hey everyone, Fuseman coming at you today, and welcome to our first live stream. So, hold on, let me just double check that we are, yeah, looks like we are rock and rolling. So, yeah, thanks for coming out to us. And yeah, this is going to be our first live stream. We're going to try and do this weekly, and let me just kind of give you a rundown of what we're going to be doing today. First, I'm going to just go over a quick introduction, do some administrative stuff, and then we're just going to hop right into developing this game. I put a reference link down to kind of what we're building, and I'll go over that shortly. Um, but yeah, that's basically it. So I guess as far as interest is concerned, so my name is Asant. I've been in VR for about 2 years now. Hey everyone, yeah. And yeah, I'm just looking at the chat now. So yeah, I'll also be periodically checking the chat, just see what you guys are talking about. And so yeah, I've been in VR for about 2 years now. I've worked at Stanford's VR lab, and I'm also helping out with a group at Stanford called Rabbit Hole. So shout out to them. And yeah, so that's kind of my background. And I'm also working with a close friend. His name is Abdo. You might find him in the chat, so feel free to talk with him. And he helped me with a lot of the 3D art, and he's a technical artist as well. So if you have any questions about that, hit him up and start up a conversation with him. There's also in the description, there's a reference link to the 3D model that we're going to be using as part of this tutorial. So if you have any questions about how that works, how he did it, feel free to talk to him. And yeah, so that's just kind of introduction. And as far as administrative stuff is concerned, I just want to talk briefly, I guess, about the reason that we're doing this. So, I mean, there are a couple of reasons. So the one primary reason is being in the VR scene for the last 2 years, you notice that there aren't too many developers out there. So we really want to get people started on what it takes to really become a VR developer. And to be honest, it's not too much, and you're probably going to see a lot of that in this tutorial. It's like the tools are there for you. It's just figuring out how to use them and then going for it, experimenting, doing projects. This is what we're going to be doing in these weekly streams. Oh yeah, and he just said hi in the chat, so feel free to hit him up. And yeah, so that's what we're going to be doing as part of these streams, is doing projects and trying to be interactive in the way that we teach. The second reason, and this kind of comes up a lot in my own VR development, is like VR, because it's such a new space, not everyone has the answers to everything, like myself included. I mean, I think even Palmer Luckey could probably say the same thing. It's like, it's such a new space, people are trying out so many different things, and we really need a community of people like working together to like tackle these problems, to actually come up with a good way to figure out innovative solutions to these challenging and new and exciting problems. So, and I think honestly the best way to do that is be very interactive in the stuff. Like, sure, there are a bunch of tutorials and stuff that you can find, but like, I really want to be interactive with people in a way that we can learn from each other. It's not just me teaching you guys, it's you teaching me and you teaching each other. That's really going to help us solve these problems as we are tackling these new challenging projects. So that's just kind of why we're doing this. And as far as, I guess, expectations for what you can expect in this live stream, this is primarily me trying to create VR projects. We've done a little prep work as far as like obviously creating this model, playing around with a little bit, but for the most part it's me solving it as if I would solve it in my own natural development without a live stream. There are going to be questions that I run into. I'm going to have to Google them. You're going to be seeing me do that, and I might have questions, you might have answers, and we can communicate in the chat for that as well. But it's really to give people also a taste of what VR development is like. So that's kind of the expectations there. And yeah, again, I'll be monitoring the chat. So if you guys run into any questions, literally about anything. So also, like, kind of think of this a little bit also like office hours. Like, I'm working on this project, but if you guys have questions like as it pertains to your own projects or like something you don't understand as part of the live stream, whatever it may be, let me know in the chat, and I'm happy to answer them just as soon as I finish that train of thought of whatever I'm working on. So think of it kind of like that way. That's just kind of where I'm trying to take this live stream, and let me know what your feedback is on that. So with that, I'm going to say we should just get started, and I'm going to switch here to the reference video that I put in the description, and this is kind of what we're going to be building as part of this live stream. So this is Jacksepticeye. In case you don't know him, he's a pretty big YouTuber in the video game space, as you can probably tell from his subscription count. And he's playing this game called Table Monster. I tried to take a look at the game beforehand, but it seems like there was an error when I tried to download it. So we're just going to watch a little bit of this video just to kind of give you guys a sense of what it is we want to do with the game that he's showing.
Japanese, so
So
understand Japanese. Translate, please. I want to know
cut a little bit to where he explains.
I control the bottom of a sumo wrestler, and I have to get food into his mouth. Food is going to come flying at my face, just all over the place, and I have to like move my head around to try and get it in. But the catch is that my mouth is all floppy. It's like messing with the Super Mario 64 thing.
Anyway, so let's just jump a little bit to some of the gameplay here. So here you can see that he's like moving with his mouse, the sumo wrestler. Now, why do I think this translates actually really well to VR is because we are, and I'm going to pause that here, is we are, instead of using a mouse, we can use our head, especially with cardboard. That's one of the primary input schemes that you have is tilting your head in any direction, as well as in most cardboards you'll have like a button or a trigger of some kind that you can use. I have my cardboard here, and this is a V2, so you have the conductive tap sensor here. Most cardboards will come with that. Some will have a magnet. Others will may not even have anything at all. So that's just kind of the gist there of what we're trying to build. And so what we have is basically we have an elephant, and what we're going to be doing is moving its trunk as you rotate, and that basically is going to simulate effectively kind of that jiggle physics that you see with that floppy mouth. So we're just gonna hop right into that. And so first things first is we open Unity. So when you open Unity, you get a list of a bunch of your projects. We're going to be starting with a brand new project. So why don't we call this Ellie or Floppy Ellie? Let's go with that. I'm just going to be saving that to my desktop, and you just go ahead and create the project. That's just going to do takes a couple seconds just for it to load up, and then assuming everything went well, you'll have Unity open, and it might look a little different for you, and that's primarily because Unity saves your window structure, so usually you'll just get the scene view with the game tab hidden back this. I generally like seeing mine to the side just so that when I simulate the game, I'll actually be able to see it. And so I know a lot of people are getting their CPU once now, and some people have DK2s. What's really nice about Unity, and we're going to be using this a little bit here as part of this tutorial, is if you have a DK2 available, you can actually just hook this up with your PC, and in real time while you're playing the game, you can rotate the device and see, and also look in the device and be able to see kind of what is happening as part of the game. So this is really good for quick testing, and then once you've kind of tested that, then you can deploy that on the device to test it out actually as a consumer would actually see it. So so this is basic Unity, and what we're going to do here just to get started is first play around with actually having an object rotate mirrored to what I'm doing. So here what we're going to do is we're going to first start with a cube, and then we're going to add the elephant into the scene and have that work. So to add a cube, all you have to do is go ahead and create a 3D object, in this case the cube. I'm going to quickly position that. And so this is your transform, and that allows you to set where in the 3D world you want an object to be. So here we're just going to move the camera, so the camera defaults to like 1 in the Y direction. I don't really know why it does that, but we're just going to put this at 0, 0, -10, and it's looking at this cube. So now that we have our cube in the scene, what we're going to want to do first actually is enable the virtual reality with the DK2 just for quick testing. Obviously, if you don't have a DK2, you can deploy it to your device to make sure that the looks right, and we'll go over that in just a second after we get something that we want to try out in our cardboard. So first things first, to actually test out with the DK2. So recently, because of the launch of the CV1, Oculus updated their runtime to 1.3. And so if you have, actually I'll pull this up here. Whoops, I want this guy. So in order for it to work with 1.3, I mean, you can obviously stay on runtime 0.8. I believe it's in their downloads. So we've got a developer center, and we're going to look for this. I believe their instructions are here. Apparently they don't have the instructions here. I think it's somewhere else. But in order for it to work with Unity, you're first going to have to update to let's see if it's listed here. You're going to have to update to 5.3.4 patch 1, I believe. And that's where the actual Unity support is. And then you have to do a little tweaking with their SDK. Let me see. Unity Oculus 1.3. Maybe that's, I think it's, did I find it here? Yeah, I think so. Yeah, this was it. Yeah, I'm trying to think. Yeah, this is what you'll need. So it requires you to get this specific version of Unity, and then you'll have to follow the steps here in order to actually set it up so you can run your DK2 or CV1. Either one works. Let me see. Quickly take a look at the chat. And so that's for setting up the DK2. I've already done these steps, so I'm just gonna hop into, once you've done those steps, what you actually need to do, and it's actually pretty simple. All I have to do is click virtual reality supported, and once I've done that, assuming everything is set up, yeah, so as you see, I rotate the device, and that is replicated in the game view. I can actually, let me pull that out so you guys can see a little better. And yeah, so I'm just rotating left and right, up and down. I can even put it on here. As part of 1.3, they do have their initial launch screen, their Oculus Home. So you just have to go bypass that by clicking through, and then you get into your development world. So yep, I see my cube. So awesome. So now we have VR supported on our DK2 for just some quick testing as we're building up. I'm just going to put that down now, minimize this, and drop it back into here. Actually, no, I want that here. Cool. So now that we have that, let's get the cube mirroring our actions. So for doing that, we're going to have to write a very simple script. So what I'm going to do is create a folder called scripts, create that, open this up, and then create a C# script. And I'm going to call this mirror rotation. So I'm going to go ahead and open that up. Come on. There we go. Should be opening up any second now. There we go. Okay, there we go. And so this is, anytime you open up a C# script, this is what you get. You get your start method and update method. Just to go over that really quickly. So there's a, okay, I'm just gonna stop right here and answer some questions. So first for Alec Nil, will the whole stream upload afterwards? Yes, it will. It'll be part of the channel. So the DK2 is from Jacob. Is the DK2 more useful for development than the CV1? That I think depends on your computer. So I mean, if you have the recommended riff specs, by all means go for the CV1. It's a better quality at 90 frames per second compared to the DK2, which is going at 75. So you'll get a better sense of, or a more realistic sense of what the world would look like. But if your primary target is mobile development, so like Cardboard or Gear VR, you don't really need that super high spec computer, then you can go ahead and actually just a DK2 works just as well. So either really works. I have a DK2 because I don't have a CV1, and I use that for quick development. But I mean, whatever you have is what you can use, really. So don't be afraid to, or don't really worry about whether it's a DK2 or CV1. Like at the end of the day, it's going to be Cardboard. It's for most people, it's not going to be nearly the same quality as DK2, the DK2 even. Developing with touch in mind. So I guess, are you talking primarily about for Oculus with actually touch controllers? I mean, I'll, I guess, wait for the stream to come back, but or catch up rather. Let me just go ahead and quickly start writing this out. So the first thing what we'll want to do with the mirror rotation is we're going to want to reference to our virtual camera. So we're going to write public camera VR camera. So what this is doing is we're creating a public instance variable that's a camera. So this is our view into the world. And VR camera, we're giving it a name VR camera. So now in update, what we're going to want to do is transform dot rotation equals VR camera dot transform dot rotation. So update is basically a method that's called every frame that you render. And so what we're saying is every frame that we render, we want whatever our transform on the current object is to be exactly what the VR camera is. So what we're going to do, this is just our first step at it. So what we're going to do is on our cube, we're just going to go ahead and drag and drop the mirror rotation. Okay, so yeah, so from the buzzer, he was asking about developing with touch in mind. So I guess in this specific thing that we're working on, this specific project, we're actually just primarily using head rotation. If you're developing with touch in mind, right now, I do have a vibe, so maybe a future project we can actually develop with, I guess, hand controls. But primarily, I think just having experimented with a little bit with VR before. With the Oculus as it is right now, it's going to be gamepad experiences. And what works really well there is you're sitting in a chair connected to your PC, and you just maybe a swivel chair or just kind of in a desktop. Whereas with the Vive, really hand controllers work the best. What I've noticed is like you really want those hand controllers only when you're in these room scale settings, where I have like the full positional tracking in like somewhat decent sized rooms that I can actually like spread my arms around. Like if I'm in this setting right here, one, like I don't know necessarily, I have my IR camera set up right on top of my laptop, but like there are definitely places here I could get Oculus Touch to be without it actually tracking, which is actually an issue. Um, and I think in general, if you're thinking about touch development or Vive hand controller development, either one of those. I think Vive controller development, at least for the next 6 months, is probably what most people might be thinking about. I really think that you have to start thinking about what would I want to do as well. First, what is my experience going to be? Second is do I need hand controllers, and if I do, might want to start thinking about a whole room so that people can use the full width of the room as opposed to like just standing or sitting experiences. Um, Let me know if that answers your question, or if you have any more follow-ups. Happy to go over that a bit more. Um, so yeah, so we were at the mirror rotation part. So now that we have the mirror rotation here, you can notice that we have this field here called VR camera, and that is exactly the same as this instance variable public VR camera. And the reason that it says none would be that I actually have to drag our VR camera into there. And now once I have that, we're going to now you can see that, and it's probably easier to see in the scene view. But as I turn the headset, this the cube turns as well. So if I'm moving a little left, you can see that it's turning left, and so it's exactly mirroring what we're doing. So I'm going to here, let me quickly see chat. Your problem to later just add touch options, would that be a problem, or would you need to think about it from the start? That's a good question. I think it really depends on the experience. Let me think about like let's say here, right? If we're thinking about this game, and suppose that instead of cardboard, we're talking about using hand tracking. Um, so in this case, we're saying that we're going to add these touch or Vive controllers, right? Now we need to ask, what does that add to the experience? So maybe if we're talking about, if we're using that table thing as a reference, maybe it's he's mirrored and I'm like bringing, you're using my hands to bring the food to my mouth, as opposed to just food kind of flying straight at you. But yeah, again, that's like a kind of different experience, right? Like actually using your hands. I mean, it's not. I'm not saying that either one's bad. It's just different. And like thinking about that, like it does. You do have to tailor what you're doing. I don't think you can necessarily like just automatically say I want to add touch controllers. I think you really have to think about like what does touch controllers add, and I think honestly like that's honestly the same thing you have to think about with every VR experience. You have to think about what does VR add to what I'm doing. Like why, like you can obviously reach a huge market already if you just create a PC game or you create a mobile game. But the power that VR really has is it shows you scale in a way that no other medium does before, and it allows people to have the freedom of choice of what they're looking at. If you think that those two are very valuable to what you're trying to convey in your experience, then by all means, like VR is the right choice for what you're developing. If you don't think that, there might be more. I'm scale and freedom to look wherever you want are like the two things that I think of, like when I think about VR development. But if you don't think that those really add any value to it, you may want to consider some other alternative to, or another medium for expressing whatever it is you want. So just like the touch controllers, think about VR the same way. Um, yeah, but it would be later at touch. Cool. So yeah, and again, like happy to keep answering these questions. So keep firing them away, and I'm more than happy to stop and take those questions as well. But looks like we're free of questions right now. So going into this, so what we just did was we added the main camera here, and that's basically the reference that the script needs to know exactly where we're rotating. But we actually want to create a mirror effect. So what that means is that the cube is actually mirroring us, which is basically it's looking at us as we turn. Kind of like as if there was a physical mirror that I'm looking at. So like when I turn to the left, it's looking at me, but my head actually turns to the right in the mirror. So the first step we're going to take to do that is once we set the rotation, we're going to go ahead and rotate, called the rotate method. And this takes in a vector 3, and a vector 3 is basically three numbers packaged together as one unit, just like when you think about 3 dimensions. And we're going to go ahead and tell it to rotate 180 degrees. So we have now two lines. One, we copy wherever the VR camera is looking into the transform.rotation object, and then the second step is to rotate whatever that rotation is, rotate it 180, so now that it's now looking at me. So I'm going to go ahead and run that. And so now, so there's a slight problem. So one, like now it actually, maybe now is actually a good time to add the elephant in so that you can actually see what's going on as opposed to a cube. So we're going to go ahead and do that just to make things a little more obvious. So in the description of the video, there's a model file of an elephant. And that's just going to be the model that we're going to be used for mirroring. And so I've already downloaded that. But if you haven't, feel free to go ahead and do that right now. If I can remember where I saved it. Where did I save it? Maybe I need to re-download it. Hold on. Is it this guy? Oh yeah, there it is. Oh yeah. Well, here it opened in it's a Blender file. So this is basically the model, but we're going to pull that into Unity. So the thing we're going to do is I have it open in my file system, but first I'm going to go ahead and create a model folder. I'm going to locate into that and then just drag my elephant in. Boom, we have that. So what that did is it created the model. And so if we click on that, so this is the inspector. This basically allows you to see all of the characteristics of your model. So that includes model, rig, and animations if there are any. And you can tweak these settings if things don't quite look like you did when you created them in some 3D modeler like Blender. It's a merge between Maya and Blender. And then also there are materials. So these are the materials that are applied to the actual model. So I'm going to go ahead and drag that in. So this is our elephant, and we're gonna here. Let me know in the chat what you want to name him. I was thinking Ellie, but I'm sure you guys are a lot more creative than I am. Let's see, let's put him back at 0, 0, 0, so exactly where the cube is. And close this. And we're going to get rid of the cube, actually. So the only thing we have to remember is we're going to copy this mirror script, and then just put that on the elephant. So I'm going to go ahead and remove that and paste that there. So that's the exact same script with the camera attached to it. And then we're just going to say bye-bye to the cube. Okay, so let me now go ahead. So you can see by rotating at 180 degrees, now the elephant's actually looking at me as opposed to looking away from me. But here's the DK2. If I rotate up, the elephant actually rotates down. And if I rotate down, it rotates up. And everything's just a little backwards. And I'm going to show it to you guys without this rotate line, just so you can see what it's actually doing. Oh, we're going with Laffy? Wait, no, I thought Laffy was the other character. But we can go with Laffy. So yeah, here it is without those. And yes, this actually mirrors it perfectly. So and so the problem here is it's not actually, so it does rotate at 180 degrees, as you can see, but it's actually a problem with a little math that they do. So actually, let me see if I can find a good link on that. Let's see, quaternion before, after. Let's probably do it with Unity listed. Maybe this one will be good. This one really doesn't do it justice. Maybe it's local global. Probably give us some better search terms. This one kinda, it's not exactly what I want. But the gist of it is really that what's really happening in this line is that it's multiplying by, it's doing this. So quaternion dot Euler or Euler, and then copy paste that. And correct me if I butcher this this explanation, but from my understanding, what that does is it rotates our object in the local space of that object. So they're kind of two different ways that you can rotate an object. One is local, like relative to itself, and the other is like relative to the world. And so you're allowed to multiply quaternions in two different ways. So you can either multiply up here for the rotation or back here. And I always forget this, but I believe that this is, I know this is the one we want because this is what we were experimenting with before. But this is in, I believe, global scale, but this is in local scale. I might have that backwards. And after I show you this, I'm going to go and see if I can get the Google links that I want. But so now if we, this multiplication is basically a rotation. And so now, did I rotate? Oh, maybe my center might be off. But now as I rotate up, it actually rotates up. If I rotate down, it rotates down. And then the left and right are the way we want it. So that's something to keep in mind when you're doing rotations in a type of mirror effect like that. So there we go. There we have that. And so yeah, so that's basically how we're gonna create this mirror effect. Is actually literally just one line of code that on every frame, all we're saying is we're going to update that rotation. 3D sound. We add sound music to this project. Would be interesting to. Oh yeah, we definitely can. I don't have any sound files on me, but it's actually really easy to do in Unity. And yeah, we'll definitely. I don't know if we'll. I mean, given that I don't have sound files, I don't. Probably won't add them today, but we can do that next week for sure. Because we'll probably be. My goal here is trying to get as far in the gameplay mechanics as possible in this hour or 2 hour stream, and then hopefully next time just kind of polishing it up to make sure like adding UI, adding sound, making it a bit more something that you could put on the App Store really. Is the idea within these next two streams, and we'll see how far we get. So yeah, so we've done the mirror rotation. So I think the next step is let's actually just try to see what this looks like in cardboard. Because I mean, the DK2 is really good for testing quickly here, but at the end of the day, we want to see this in cardboard. So how do we do that? So the first thing we're going to want to do is, I don't actually have this downloaded. I was just going to download it as part of the stream. So I'm going to go to cardboard. And I'll say right now that hoping that at Google I/O in, I think that's May 18th, they announce the native support for the Cardboard SDK, because I think that would be really cool. So we're going to go ahead and download the Unity package for the Cardboard SDK, and boom, that's just in. Just go ahead and click that, wait for it to load. And yes, we want all of this. Go ahead and import that. Takes a couple of seconds. They keep adding things, and the more they add it always, takes longer. Cool. Actually, let you guys decide, honestly. I can put some background music if you want. I'll let the choice be up to you guys. It's like if I'm actually trying to simulate what it is when I'm developing, I'll usually put some like background instrumental video game music on. It's always inspirational. But okay, let me know if you guys want that. So now we have the Cardboard SDK in, and that comes in its own folder. And so there's a bunch of stuff in here, but what we're primarily interested in is the Cardboard main. We just go ahead and drag and drop that in. It starts at it starts at 0, 0, 0, but we actually want to start at exactly where the previous camera was, which is at 0, 0, negative 10. And we're going to go ahead and disable the previous camera. As you can see, the background changed to a dark blue, and I don't know why they made this choice for cardboard. Actually, no, I kind of do know why. It's because it's an efficiency thing. But so Unity gives you this nice default skybox that you have here. You can actually change the location of the sun. Thing specific to turn that on or off. I mean, yeah, actually, I mean, the reason I don't have the positional tracking in right now is because I'm out of USB ports, if I'm being honest. But yeah, I believe, and I need to double check this, but I believe once you just plug in the IR camera, it should give you that data as part of the SDK. If you're following along, try it out. Let me know. But yeah, that's primarily the reason. And also with cardboard, you don't really need you don't have positional tracking. So I mean that's something that I'm not terribly worried about right now. But yeah, it's definitely a nice feature to have. That's for sure. So yeah, as I was saying, Here's the background's blue is because for their main camera they decide to make it a solid color as opposed to the skybox. So we're just gonna enable the skybox because we can, and I like the skybox a lot better than the blue. Um, but I think the main reason that they do that is just efficiency. Like a solid color is a lot easier to render than a texture, and that's just kind of the primary reason there. But like once we have that, we can run it. There is some simulation you can do if I remember correctly. So okay, so Control lets you tilt, and Alt lets you change it like that. And as you can see, the elephant isn't rotating, and the reason for that is because if we go here to the mirror rotation, it's our reference camera is the main camera. It's not our cardboard camera. So I'm going to quit play because then that'll enable us to go ahead and save that change. So anything, oh yeah, we should also, I should also mention, so anything you do in Unity, you're doing in a scene usually, um, and you can save those scenes. So I'm going to just quickly go to scenes. Um, let's see, this is Ellie, or what was the name we gave it? Lofi. Lofi game. Let's just save that in the scenes. So now that's an actual file. And now, yeah, so now it turns as we turn. And so what I'm doing, because I guess that's not obvious, is Alt and then left clicking on the mouse to simulate turning. And you can see that if I highlight the main camera, you can see that the camera is turning directions. So there we go. So that's turning the camera around. You can also tilt EleNoms. Oh yeah. Noms is Noms is a good word to use there. Maybe that's the name we'll go with. Unless someone comes up with a better idea than EleNoms. But yeah, so you can tilt as well. So that's simulating it, but I want to show you guys like what you need to do to actually get it on your device. So with Android, it's actually really easy. So the first thing we got to do is go to Android. Sorry, so first add open scenes. So that's just kind of the first thing you want to do. Then we want to switch to Android and switch platforms. That, depending on how many assets you have, can take a while. And we don't have too much other than cardboard, so hopefully that's fast. And so yeah, so that just runs. It's just basically what it's doing here is taking your assets and optimizing them for Android as opposed to PC. So there's that. Oh, looks like we're done. Then we're just going to go into player settings. One thing we want to note is, so there is a virtual reality supported thing, and this is what I was talking about when we're talking about the Unity native support. Like, hopefully in the future, that instead of it just being a checkbox becomes like a drop-down, so you can choose Gear VR or Google Cardboard. Right now, when we do that checkbox, it's solely for Gear VR. So if you left that checkbox on, it would compile this as if this was an application you're trying to deploy to a Gear VR. In this case, we're targeting Google Cardboard. Obviously, like it's pretty easy to like port this over to Gear VR, but we're not trying to do that right now. So we're just gonna deselect that. We need to come up with a bundle identifier, and here we're just gonna go com.fusioned.EleNoms. We're going to change this minimum API to slightly higher. I think it does. That results in some more optimizations it can do. Obviously, if you do want to support lower APIs, you can do that. And that is pretty much it. I should. Oh, okay, yeah. Let's change some of this stuff. So the company name, product. The company name is not too important. Fusion. The product name is what is going to be the app name, basically. Um, and then publish settings is like, this is important only when you're actually going to deploy it to the App Store. You're going to actually want to assign it with a cryptographic key as opposed to the unsigned debug key that you see here. So what we're going to do is, let me open up my phone. But with that, because I've done Android development before, it knows some of my settings already. But if this is your first time getting started with Unity and Android development, um, what it'll ask you to do is download the Android SDK, and then it wants a pointer to wherever it is on your file system. I've already done that, and Unity remembers that. So if we just go ahead and click build and run, it just asks for what we want, or where we want to save the file that it creates, which is an APK file. So I'm going to create a builds folder, and this is going to be test v1. So we just quickly create the APK and let that go. So that, again, it's not a terribly huge file, so it'll happen really fast. And we'll just let that go. Hopefully I didn't forget anything. And yeah, the process for iOS is a bit trickier. You don't have this like build and run feature for iOS. Oh, so one, you need to be on a Mac. Two, what happens is you export it out as a Xcode project. Cool. So that. Oh, I did forget something. Here, let me go ahead and drag this in. Well, what you can see here. Oops, I think it crashed because of this problem. Actually, I can simulate it. So we're just gonna bring this up. But yeah, it's crashing because of that. But so one thing I did forget, and I kind of wish that. Oops, I don't want to do that. I kind of wish that this was just kind of built into the SDK. But when you're building for Cardboard with Unity, you got to make sure that these settings are only landscape right or landscape left. So we're just gonna deselect these. We're gonna default it. Yeah, we're gonna default it to landscape left as opposed to the auto rotation, and then just go and rebuild that. Yeah, we'll replace it because that was a failed test. Yeah, so that's just kind of one thing to note. There is you don't want Cardboard coming up in portrait mode or rotating willy-nilly. You just gotta force it to one thing and then drop it in the viewer. So I'm just gonna let that go. Cool. So where is it? There we go. Okay, I just realized that this is a problem. But okay. Funny how that works. So for some reason, it thinks my rotation this isn't actually me facing you is not forward. It's facing back here, and that's I guess one issue with Cardboard. But yeah, I'm using an app called MobaZen right now just to mirror whatever you see on my phone onto the screen. But that's also backwards, I think, because we're looking backwards. So yeah, so as you can see here, it's just we have it now on our device. For iOS, it's a bit more complicated of a process. There are instructions out there on Unity on how to do that, but yeah, and yeah, they'd say that it's free, although I do have a paid account, so I'm exactly um, not sure exactly like what the exact process is behind that. But I think it's possible to do it for free to get Cardboard onto your iOS device. I think you have to sign up for a developer account, um, and might have to jump through some hoops. Um, but in theory, yes, it's possible. And yeah, as far as this app is concerned, we'll try to get it onto the iOS store as well, once we have it ready for Cardboard. Um, but we'll see how that process goes. So yeah, so that's now we have a very basic thing. We basically have our first Cardboard app. So there you go. If you've been following along, you now have a Cardboard app on your phone. How awesome is that? And it actually does something with 2 lines of code, right? Um, so that's awesome. Uh, can you test your app for free on iOS? I believe you can. Like, I think they recently allowed you to um, publish without paying the $99 per year to your own device. I have not successfully been able to do that, but I think I've heard people that can. So I want to say yes. I've never done it before though. So if you guys figure out how to do that, let me know because I definitely want to know how to do that. But I have developed iOS push to iOS before, but I do have a developer account is the thing. So yeah, so that's our first Cardboard app. Cool, awesome. Um, yeah, okay. So now I guess what more are we at as far as time is concerned? We're about 45 minutes in. Um, let's just keep going. I was considering taking a quick VR break to show you guys a couple things in Lucky's Tale, actually. Some design decisions they've made that work really well with it. Let me know if you're interested in seeing that. And some of those design decisions will apply to us here, which is why I want to actually take that break and do that. But let me know if that's something you guys are interested in. Otherwise, I'm going to keep chugging um, for a bit longer. So, cool. So let me go ahead and close that on my phone. And now that we have the elephant, so as part of that game that I showed before, let me make this bigger. One thing that they do is, so you have a giant mouth. So here, so Abdul did an awesome job in rigging this. We still need to do a little bit work on the model, and by next week, hopefully have a lot more things rigged as that we can control with this. Um, um, and I guess I should also explain what rigging is. So when we're talking about, and I'll explain it from the Unity side. Abdo can explain a lot more about what goes behind the scenes as far as like rigging in 3D creators like Blender. But from the Unity side of things, what that basically means is we have a 3D model, and as far as Unity is concerned, that is a skin mesh render. And what that basically does is in Unity speak, you basically have a bunch of these game objects that I can control. And the skin mesh renderer looks at the location of those objects and then maps certain vertices into certain locations. So the core of the idea is really coming up. Basically, if you think of uh, this mesh, this elephant here, as having a skin, these game objects here are basically the bones that, as I pull the bones into certain positions, that allows it to form the skin around where those bones are. So here, we can see here, in the default state, this mouth is pretty small. And if I go ahead and actually I'm gonna rotate it from here. Um, I rotate it a little bit to like make this mouth super large so that we can actually feed this elephant. And okay, yeah. So now I have the mouth wide open, and we can actually animate this later on. So say like if food comes in, like we wanna eat it, we can have the mouth open and closed like that. Um, so yeah, we're just gonna leave that default there for now. And so now we have the mouth open. So now what we want to do is make this trunk swing. And looking at the way that they did it in that video is basically, so they had exactly what we have, a mesh that has these bones that are in the cheeks and the mouth that they could manipulate. And we want to manipulate that with physics. And so the way the physics system works in Unity is you have rigid bodies, and you can create joints as well. So here what we're going to do is on the whole elephant object, I'm going to create a rigid body. We don't want gravity to take control of this, and this one is actually going to keep freeze the position and rotation of it. So we don't really want physics applying onto the whole game object, but this is going to be important in the next step. So the next step, we need to actually go find the bones of the trunk that we want to control. So that's, as you can see, I can zoom in a bit more so you can actually see that happen. But that's these bones right here. Those are all of the bones in the trunk, and if I go ahead and actually rotate them, you can see what that does to the trunk. So yeah, so you can rotate that one, you can rotate this one, you can rotate it. It looks a little wacky if I rotate it that way, but that's like also kind of how an elephant would, if it had the ability, I guess, to twist its nose, which hopefully, actually, no, I don't know if elephants can do that. I guess something to go ask elephants one of these days. So the thing we want to do here is create joints. And the way that Unity has them set up, there are a bunch of different joints you can do. If I just search for joint, create a character joint, you can create a configurable joint, fixed joint, hinge joint, spring joint. Fixed joint is the basic one. You have spring joints. Configurable joints are obviously the most flexible. But what we're going to actually use is a hinge joint. And actually, why don't I go ahead and bring up the documentation for that. Unity hinge joint. Alright, so hinge joint groups two rigid bodies together. It's basically kind of simulating what a door would be like when it opens, like on a hinge. And you have a bunch of different properties that we can play around with, and that's really cool. So we're going to go ahead, where's Unity? So we have a hinge joint there, and in order to basically create that trunk moving effect, we're going to need to, on all of these bones, attach a hinge joint to them. So we're going to do that for all of these. I think this bone is like deep inside, so we actually don't want that. And then we chain them together. That basically tells the hinge joint, it's like, look, I'm connected to this object and I need to move along with this object. So we're gonna chain them in a row, and this is where that ridge body is. We basically are telling that bone specifically to be connected to the whole elephant. So there we go with that. Took off gravity. I don't want drag. Just have these things move freely. And yeah, okay. So let's just see what this looks like here. Okay, so just again for going back to quick testing, I'm gonna go ahead and actually disable the card. Well, actually no, we can keep that. Probably a little better for now. So as I rotate, so nothing's really happening, and so the reason for that is because everything's actually connected together, and I'm rotating everything as a unit. So there isn't actually any gravity or anything getting applied to anything. Um, so what we actually want to do here is I'm going to create an empty game object, put that at 0, drag the elephant under it. So this is it's called parenting, what I'm doing right now. And basically, think of it as almost like a way to group objects and have anything that anything affected on the transform. So for example, if I move the, let's call this grouping. If I move this grouping back and forth, it moves everything that's underneath it with it. And that's just kind of what parenting does. What I'm going to do actually is move that bone outside. And so the mirror rotation, it applies everything to the elephant, but it's not going to be applying to this one. So this one we're going to let gravity do its thing and simulate kind of like that trunk moving all around. So now if we go ahead and as you can see, it kind of already did something to the trunk, and it's a little twisted, and part of that is because we're allowing it to rotate in that Z direction. But as you can see, as I rotate my my elephant, there is physics being applied to that nose. So we're on the right track, that's for sure. And let's see. You left some freeze rotations on. Maybe that should be on for the body I saw. Yeah, are you talking about yeah, the elephant model, or are you talking about the bones down here? Yeah, well, again, waiting for the stream to catch up. It's like streams are like pretty interactive, but there is always going to be that 15 or so second lag. That's part of the trunk, but it looks like let me just double check. Didn't miss any. Nope, I think this is what I want. That might change. You never know. These are just, I guess, things you got to play around with, right? And not a problem. Holo Leo. Happy to do this. Like, this is what I said at the beginning. It's like, I think it's just a way for us to, like, as a community, start working on really cool projects. And like learn from each other. So this is why I'm doing this. I'm happy to do this, and I'm hoping you guys get a lot out of this. And again, yeah, let me know if you want to see something that I missed, or if there's just something completely different you want to see. I want to keep this interactive, so for sure, just let me know. Be honest with me, and yeah, I want to make this awesome. That's what I want to see. So yeah, cool. Moving right along. So now we have So now we have the bones there. So if we go actually to the documentation, so we did the connected bodies thing. What we want to look at, I want to draw your attention to, is the axes. So what is the axis? The direction of the axis around which the body swings. We're talking about a swinging trunk. Makes sense. The direction is defined in local space. So it's a little like if like the first time I read that, honestly, I was like a little confused about what it meant. And so I had to like I tried like playing around with it a little bit. And so what I think Again, this is what I think. Maybe someone else can explain this better than I can. But it's basically like from playing around with it, some of it didn't quite make sense the way I wanted it to. But what I'm thinking is, so the reason you got that like huge, oh wait, there are actually two regions. I totally skipped a step. Sorry about that. Um, so the first thing, like from reading tutorials about like how hinge joints actually work, um, you have to make sure that this use limits is checked, and then you're gonna have to set the min and max limits here. So let's do that first before the axes. Here, click use limits, and we want this bottom bone to be rotating, like have full range of motion. Um, and I'm just gonna go ahead and select, yeah, we put hinge joints there. So just gonna use limits and so selecting those both. When you multi-select in Unity, um, if two objects, all the objects, sorry, that I should say, all the objects that you select, if they have similar properties, then you'll see them listed in the inspector. If they don't, then it'll only show the common ones. So in this case, like bone 2 and bone 3 both had rigid bodies, both had hinge joints. So I was able to see them and I manipulate them at the same time. So that's really useful if you have, say, potentially 100 different objects out there. Um, you just want to manipulate them all at once instead of going one at a time, because that could get really tedious really fast. Uh, and so, but for here, we actually want to change the limit slightly. So the higher up we go, the less flexibility we want to give it. So let's do like 120 to 120 and negative 150 to 150. I played with these numbers a little bit before, but I'm still not 100% sure if that's how much flexibility you want to give it. That we will have to play around with, and that's just kind of the beauty of development. So yeah, okay, so that alleviated some issues. It's not twisting nearly as much as you can see at the top guy. Because of those limits, he turns ever so slightly, but he's not like twisting around and around and around. So that fixed one problem. The other problem that we need to solve is that twisting. And so again, going back to that documentation, it is more to do with this axis. And hello, I could be totally butchering this name. Sophia. Let me know if I pronounced that right. um, so you have so this is the axis that you wanna. Okay, so Jacob. So Unity is what I know. I don't really know Unreal or CryEngine. If you guys are interested in seeing me learn how to do that, I could definitely make that as a live stream. Or I might be able to find someone. So I've done those Unreal pretty well. So he could probably lead something if you guys are interested in like getting the basics of how to get that set up. Neither of us know CryEngine or I believe Amazon's is Lumberyard now? There are a bunch of engines popping up. Yeah, Unity is my strong suit. Abdos is Unreal. If you're interested in seeing those, we can teach those. I can potentially try to find someone to lead a CryEngine or Lumberyard. There aren't that many experts out there on Lumberyard, so probably not Lumberyard. Maybe CryEngine. Try to find someone. But yeah, I think primarily it'll be Unity to keep that answer shorter. So yeah, so the axes. So what we're gonna want to do is what is the axis we're rotating on here? So the axes that they default to is 100, and so that axis. And this is again why I'm not 100% sure, and it might be because the bones are already rotated a little bit. No, not really. But if so, it's saying it's local. So what that means is if so, the x direction, yeah. So we can see here. So it says what the x direction is, um, and so that's represented by this red arrow. So if we, I guess, are rotating here, like if we have the trunk coming down and we're rotating here, what I would have imagined is a bit of contortion in this direction, which is not exactly what we're seeing. Um, and that might have to do with the way it's connected. But what I do know is that the axis is the axis is the reason that you see that. So what we're gonna do is actually just change that to be in the 0, 1 direction. So I'm gonna do that for all of them. And now we're gonna try this out. And it goes crazy. So obviously, as you can see, the axes did do something. Oh, okay. That might have to be because I left gravity on there. Nope, still not happy. Let's see. Yep, this is where, like I said, things. This is just typical development process. It's like you take a look at something, realize that it doesn't do exactly what you want, and then you gotta figure out how to fix it. Um, let's see. So they actually let me try playing around with 0, 0, 0, 1, both here and there. Okay, so that did something. Not exactly what I wanted. Um, but it is something we can play around with, that's for sure. So the scene view might, again, still probably gives you a better sense of what's going on. Oh, come on. Okay, I might, here. Cardboard is being a little tricky to use. So what we're going to do instead is we're going to quickly switch back to using the DK2. So then we'll put the main camera back in. We're going to find that elephant, drag this main camera in, and where's my build settings? Build settings here. I'm gonna go to other and do VR supported. And so the VR support here again is Gear VR, but when you're in the Unity editor, that means that it'll be running on the DK2. It actually, I mean, there is no way for you to connect your Gear VR to your Unity development. I'm hoping that's something Carmack is working on because that would be really cool. But at the moment, the Gear VR is actually a pretty close system, and is honestly one of the reasons why I'm doing cardboard development in the first place. For example, it's for a live stream like this, it's impossible for me to actually show you guys what I'm working on in the Gear VR, because they've taken optimizations to make sure that no background services are running while you're in the Gear VR. And to be fair, that's a good thing for them because that means that the VR solution that they do is optimized so that like you get the best performance out of your Samsung phone. But for something like this, where I actually do want to show you like what is going on, I do need a background service running, which is Mobizen in this case, in order to actually capture whatever's on the screen and show that for you guys on the stream. And for something like that, yeah, it's not gonna work. Hopefully, like just like they did with the video recording and the screenshots, I'm hoping they do something for live streams because that's also a really great way, in my opinion, to share VR content. Hopefully we'll see that. I'm pretty sure Carmack's working on something like that. So now that we've done this, I'm gonna go ahead and actually like look at this in in VR. So as you can see, I like rotate my head, and that trunk is moving back and forth, a little wonky. But yeah, I can like it kind of moves similar to where I want it to go. And actually, this is actually working a lot better than I thought it was going to. This is way better performance than I thought it was going to. But yeah, as you can see, I'm like rotating my head. That trunk is swinging back and forth, left and right. I could do this for a while actually, but I'm not going to. And yeah, it'd be kind of funny to like build a game where you actually like try to use the trunk to feed yourself. That would be weird. um, yeah, that would be pretty weird. Um, yeah, actually, it worked a lot better than I thought it was going to. Because when I played around with this before, when I played around with it before, it was it worked. Don't get me wrong, it worked, but not nearly as well as that. Um, let me quickly read through the chat here. Head tracking controllers, lean motion, whatever you can come up with. Yeah, absolutely, Jacob. I think, yeah, we're just going to come up with a bunch of projects and just kind of hammer one at a time at them. We decided to start simple today with cardboard, just to kind of get the ball rolling. But as we go along, definitely want to get into more and more complicated projects. Camera systems, touch controls, UI. Yeah, absolutely, Ben. We'll go into UI probably next week. And I do, yeah, like I said before, I do have a Vive, so I'm totally down to do some Vive development so you can see kind of what it looks like to do camera controls. Let's see. Oh, multiplayer for VR, actually, that was actually probably going to be one of my next topics. I don't know if you guys have seen Tilt Brush, and I don't know how realistic we're going to get with this, but what I want to do, which would be really cool, is you have one person in a Vive um, who's able to draw, and then you can have people at home who have cardboards would be able to kind of view in real time what that person's drawing and interact with them. I think that would be a really cool social experience. More than like the tilt brushes, like people, or like when you see like fantastic contraption, for instance, that's people looking at a monitor. But like if people could like look in VR and like see what you're doing in VR, it makes tilt brush like so much cooler to the audience. So really want to build that. And I'm sure there are a bunch of other multiplayer VR stuff that we can do. So let me know what you think about that. I'm excited about that. But yeah, let me know. Let me know what you guys think. Um, so yeah, so we have an elephant. Its trunk is moving. Um, what time are we at now? 11:20. Um, what do we want to do next? So we could. Here's what we're gonna do. We're going to deploy this to cardboard, but the first thing I want to do before we do that is add a reset function. Because as you saw last time, like I wanted cardboard to be here, but it was actually over here. Um, and being back here actually made the mirror functions a little wonky. So what we're going to do, and that actually might have been because I chose landscape left instead of right, which could have been a problem. But let's add that reset in and make sure it's actually working on cardboard the way we want it to, because it's always good to like test stuff while you're going. So we're going to do that, add that reset functionality in, and by reset functionality, what I mean is the ability to we're going to tap on the screen at like wherever we want. So like if we're holding it here and I tap on the screen, I want it to reset there. So we're gonna, oops, and I accidentally clicked when I didn't want to, and I created a random script. So we're gonna go ahead and create a new script. I'm gonna call this reset on tap. Boom, done. Created that, and I'm gonna open that up. And what we're gonna do here is on start. Now this is how much do I remember that cardboard SDK. So Actually, I don't want to go SDK. I want to go on. Oh no, I do want to go SDK. On trigger. So what we're doing here is using C#'s event system. What that means is these are methods or functions, whatever you want to call them, that are called whenever a certain event happens. So in this case, it's whenever the trigger being like whenever I tap on the screen or whenever it realizes that a magnet was pulled. Um, that is going to be that's when this method of ours is going to be called. Um, so so on trigger plus equals, I don't like that name. Let's see, reset VR. This is the method. So what we do here is with the plus equals is we're saying anytime that on trigger action is called, we want our method reset VR to be called, and we do that with the plus equals. Good practice is whenever, whoops, there we go. So whenever we add a function, we always got to do the opposite and remove that function, so that the SDK knows that, oh, we're done calling this function. And the good practice here is so the opposite of start is on destroy. So whenever we've created this the script, the start function is called, and that's going to do the plus equals. Whenever the script is destroyed, it'll call on destroy and it'll do the minus equals. So that's just cleanup. It's good practice to do. It'll help you avoid bugs. And I've run into plenty of issues like where this thing crashes because you forgot a minus equals in there. So just remember to do that. I mean, it's again not a big deal when you're testing things, but still good practice to do. So what do we want to do in reset VR? So when that trigger is pulled, what we're going to do is Cardboard is really nice, and they give us a recenter function. So we're going to do that. And just like that, we have a reset when things are tapped. And we just got to make sure we add that to our world. So I'm just going to create an empty game object. I'm going to call this reset manager. And we're just going to drag that in, and that's good to go. So the last thing we're going to do is reset this again for Cardboard. So pull this open, go to the elephant. Oh wait, no. First, find the reference to the main camera, go to the elephant, and drag this camera in. Save that, and go to our build settings. Double check that this thing is turned off. And we just click build and run, and we'll just call this V2. I mean, we could all. I don't know if this is bad practice or not. So I usually do overwrite my V1s and V2s until I come to like a consistent build pattern. Here I'm gonna try to keep a lot of the previous versions. So I'm gonna create a V2, but if you don't care about your previous builds while you're doing quick tests like this, go ahead and overwrite them. So I'm just create my drag this over so that you guys can see what's on my device. Take a quick drink of water. Water is great. Gotta love water. And hopefully that gets ready soon. Yep, there we go. So assuming I did everything right, if I just tap, yep, there we go. It resets, and so now I have it in Cardboard. And actually, let me see how it actually looks in Cardboard, which is always another important thing to do when you're doing VR development. You gotta actually take out the devices that you want to develop for and put them in. Granted, right now I forgot to take my case off, so this is going to look a little. Actually, it doesn't look that bad with my case on. I can't close it, but I can definitely drag this around. And yeah, frame rate like for Cardboard looks pretty good. Gotta do like some quick quick movements here to just see if it like lags out any frames. But it seems to be working pretty smoothly. And this is pretty cool. Just we already have something on cardboard that's like, even as a viewer, like this is still pretty fun to play around with. Just having this trunk moving and doing what I'm doing. And basically makes you think less like, huh, I'm a little elephant in the mirror. That's awesome. That's so cool. Sweet. Well, there we go. Let's see. What do we want to do next? How are we doing on time? 45. Oh, that can't be right. Not 45 minutes in. Wait, really? No, it's 11:25. I've been doing this for about hour 25 now. Tell you what. Why don't we? I'm gonna go ahead and get some assets for next time, and then I want to end on Lucky's Tale, and we'll call that a stream. So one thing I want to really point out, especially if you're getting new to, if you're like brand new to VR development, or like if you're in game development, you probably know this, but like Unity has a bunch of free assets and paid for assets on their store, and it's a really great tool. If you're just getting started, you don't have 3D modeling experience yet, and you just want to build, like maybe art is not your thing, just like me. I'm a horrible artist. You put me in Tilt Brush, you're just going to see scribble scrabble all over the place. But the point being is like a lot of people have developed stuff that you can use for free. And that's really, really a great resource. There's this. There are a few other locations like Turbo Squid. Totally blanking out on some of the other ones. TF3D. Actually, Stanford does have a research library of 3D models. I need to find the link to that, and I'll let you guys know. It's research only. And like I think it's I don't know, I can't remember if you can download them, but there are a bunch of models out there, and that's really cool. But here, the reason I want to bring us to the asset store is just like in that reference video. It's basically a bunch of different really objects like that are coming at you, and you need to try and get them into your mouth, right? I got a question there. How do you add atmosphere in Unity so objects that are far away are faded or blur? Does the engine do it by itself? Oh, sure. We can do that. That's actually, let me close that for a second. Drag that over here. We can add that right now. I don't know how good it's gonna look, but we can add it. So if I remember correctly, it's in lighting. Yeah. Cool. So what you can do is if you go to window, where is lighting in here? Oh, lighting. There it is. Lighting. It'll bring up another window that basically controls your scene. So this is where you can change your skybox. This is where you can, if we actually drag this directional light in here and rotate it, we can actually, this specific skybox allows you to play with night and day, which is really cool. I really like that. It's the default. I'm just gonna undo that. But going back to your question, how do you create that faded look? It's with fog. So if we go ahead and move this grouping off into the distance, we can you can kind of notice it. I don't know how this is going to look on the stream, but it looks a little faded compared to like when it's a lot closer. And this is actually using exponential squared fogging. We can do linear fogging, which is basically it'll create a linear gray fog from 0 to 300. If you want, you specifically asked about blue, if I remember correctly. Yeah, faded or blue. Whoops. So yeah. So we can actually just change this light to be blue. I don't know what color is going to get us a good contrast here. Maybe a light blue. Yeah, you can see it. So yeah, uh, Raleigh scattering. Actually, I have not heard of Raleigh scattering. Let me Google that and see if it is. My guess is it's gonna be a specific type of fog. Raleigh scattering is a type of fog. Refers to the scattering of light off of the molecules off the air and can be extended. No. Well, what do I want to say about this? So Raleigh scattering. Okay, so from based on my understanding of this quick thing here, this is like how it physically actually works. And so I guess the direct answer to that is the way Unity does it. The answer is no to that. It's a very like cheap trick, honestly. It's basically what it's fog is doing is basically as you get further away, it adds a little filter to whatever you render um, to give you that fog effect. So like for example, um, I've just hear of it flight sims. Oh, I yeah, flight sims might have their own fog because based on the higher altitudes they don't this cheap trick for fog doesn't really work there, but like really all that it's saying here is um as objects get further away, we intensify this filter that we're applying to the object um, until it's like invisible. So like as you like you can I can't tell if you're gonna see this on the stream or not, but it's something you can definitely play like just throw any object honestly into Unity and see if you can play around with it. Um, Actually, that might help if I scale this up a bit more. So let me make this 10 by 10 by 10. Yeah, you're definitely gonna see it now. Um, yeah, so as I pull it out further and further away, it becomes like a very light blue, and that's just this is a linear fog. You can have more subtle effects like exponential. It's like that's just depending on like how dense you want the fog to be, and then there's also exponential squared, which I think is just a steeper curve on um, how much fog you get based on distance. Um, Hopefully that helps answer this type of question of like how to add that feature. Um, how much does the VR sense of scale for large distant objects depend on fog or atmosphere? Um, so the thing with VR, I guess, is you really get depth perception around. So in Unity, every unit is basically a meter of if you're thinking trying to compare virtual space to reality. So it's like every one of these square grids I think is 1 unit, and that's about a meter. Just to give you a sense of scale. And so the thing about like the way VR depth perception works is you get like really close to your face, like it's really hard on the eyes. It doesn't really you do get a lot of depth perception, but the stereoscopy because it's so close like makes it hard for your eyes to converge. Around I want to say like 3 meters to 25 meters, you're gonna get a pretty good sense of depth, and that sense of depth like falls off as you get further and further away. So if we're talking about large distant objects in the background, honestly, like you won't get too much depth perception from that. And like it's kind of the same as real life. Like distance objects off in the distance, you don't really get a good sense of scale until you're like pretty close to it. The same kind of holds true for VR. Not exactly the same, but you kind of get the idea. And as far as fog is concerned, um, I don't think I haven't played around with it, so I don't actually know like if like how best to answer like how fog really affects your sense of depth. But my guess is, especially like if we're looking at it here, I mean, the way Unity is handling the fog, it kind of just becomes like a 2D object because like you get the fog makes it like so opaque that the lighting doesn't really apply to it anymore. Um, Not sure if that answers your question. Hopefully it does. I think that's how much I know about like how fog actually plays a role in here. Um, yeah, but I'm gonna go ahead and actually turn that off and bring this object down to size, and I've made it, yeah, it's not way too far, but yeah, bring that down to 0. Um, right, so asset store was where we were at before, and yeah, that's where I'm gonna end the development side of things. So like I was saying, great tool to get assets. What we're gonna do here is we're gonna just honestly just find a bunch of free. Yeah, we'll just click free only. 3D models. What handles? I think Unreal actually handles it the same. Abdo can answer that better for you, but I think it handles it the same way because um, realistic fog is a pretty hard trick to pull off, I think. Um, but yeah, Abdo probably has a better answer to that than I do. Let's see. So what I want to do here is just get some props, get some vegetations to feed the elephant. Um, I don't want vegetation. I want well, maybe I do want vegetation. I don't know. I don't really like any of these. I want where do they put the fruits and stuff? That's the stuff I want. Really random stuff to feed. We can put some food in there. We can probably put some it's under characters. What's under characters? Other? Okay, let me figure out what fruits is under, honestly. Okay, well, let's search fruits. Sort by price. It's 2D. Wait, really? There's no free only. Really? There are no free fruits. Huh, can't see that. Veggie table. Let's see. No fruit. This is also a new sorting scheme, so I'm not really sure. I thought there was free. There are definitely are. I'm wondering if I'm just not searching right. Um, which is probably true. I don't think it's any of those. Maybe let me search from the top by not by name, by price. Um, okay, maybe it's not here. Unless that's what these things are. Oh, okay, that's an actual package. Okay, so in that case, if we can't find anything there, I'm gonna go ahead and go to TF3D just to show you guys what you can get here. There's like a bunch of different stuff. You can get we just want to be looking at the we want to look at the extensions, um, and ideally it's FBX. FBX imports the best into Unity, but anything like 3DS might require a plugin. OBJ doesn't. Um, Maya definitely does require a plugin. I think DAE is fine. Let's try the apples. Um, these apples could look really weird. I'm not sure. Yeah, let me know in the chat if you find anything, any random. Oh, I totally clicked the wrong download link. So silly. Um, Let me know in the chat if you find anything that you think is interesting, and I am more than happy to put it into here. Don't have to worry about those models being too high poly. You do. that is actually a very good concern. And we will take a look at them and see if they're reasonable. But there's only one way to find out, really, is just to like look at it. Um, oh, whoops! I need to open it with 7-zip. Download. Let's see. Open archive. And we're just gonna extract that into downloads. Open this up. And okay, so they have a material file and the object. So we're gonna do, let's close this. Go to models, and then drag and drop the. Wait, let's first try and drag and drop this, see if it works. Oh yeah, beautiful. So okay, they have a bunch of apples in here. I'm just gonna drag. Oh, this is huge. That's another thing. That's another thing about getting random models off the internet. Is sometimes come up. It's not exactly what you wanted. But that's fine. What is this? Okay, so let's just take this off of whatever I just imported and delete the rest. So that's our apple. Now let's see. Let's just rotate it back to normals. So seems to be the time to see what's new. Yeah, it might be. And yeah, I mean, we'll see if we can get a separate set of live streams going for UE4, because yeah, I think both are valuable. Like my opinion of UE4 is, if you're trying to do high-end development for PC, basically Oculus, HTC, I don't think Sony really applies here. We'll just say like Oculus and HTC, like Unreal definitely gives you some nice looks as far as graphics is concerned. There's no doubt about that. But if you're like targeting cardboard or gear, you can get Unreal to work, but I think it's a lot more. There's a lot more work involved, and like you have to tone down a lot of the graphics, and bake a lot of things in order for Unreal to be reasonable, as a choice. And it's just designed to like really what are you targeting, and using the right tools for that. So like because of Unity's like lower constraints and better optimizations for mobile, it makes sense to do that for cardboard or gear, or any mobile VR. But yeah, Unreal is definitely good for Oculus and Vive. I'll give it that. What was I looking at? I was looking at this apple. If we look at it, it is actually, it's not too bad. I mean, you can obviously like shrink down the number of polys on verts on this thing. If we take a look at the stats, just running this here, I'm going to throw this into the scene. What do we got? We got 37.6 and 85.7. If I get rid of this, that's honestly not that huge of a difference. Like this is actually like pretty reasonable for mobile, so we could totally use that. I should also just double check to make sure they use media. Shoot. Let me go back. What did I use? I used TF3D, right? I also just want to make sure like the well, with the licensing, yeah, personal use only. So we'll use it for now. This is still, I mean, pretty personal use, but I guess in the future, like if you ever want to like publish something, just make sure that like you look at this license when you're looking at TF3D, it can bite you in the foot if you don't pay attention to it. I mean, it's not really like a huge problem for this, but if you're doing anything commercial, like something to keep in mind. Yeah, I think for the sake of not boring you guys to death while I go and search for a bunch of different models, why don't we wrap up the development here, and I'm gonna go ahead and probably for like 15 minutes I'm just gonna like play through a level of Lucky's Tale, and I'm just gonna point out some of the things that I noticed that were good design choices and bad design choices that they made. And kind of tell you guys like how that'll be relevant here as well. So let me just like close this up. Probably take me a minute or so to set up here. Can I close all of this? Yeah. Close you. Close you. I don't know what that is. Close you. And yeah, alright, so going to also for if you guys have a DK2, actually I don't know if you need a DK2 for this, but it's a random side note, and I don't know if these are still free or not, but if I would highly recommend installing the Oculus Runtime 1.3, and go ahead if you ever have any plans for a DK2 or a CV1. Go ahead and download Henry and Lost, because they are free for a limited time. So I don't know when that limited time is. I'm assuming it's once they finally get all their pre-orders out, which could be a while. Yeah, if you haven't, I highly recommend that you go ahead and do that, because who knows how long that'll be out for. Just plug you in, plug you out, plug in the Xbox controller, and I think that's everything I need. Alright, so alright, there we go. So one thing I don't appreciate about Lucky's Tale right now is that the mirror here is so tiny, and there's really no way to make that bigger. I'm sorry about that. But yeah, okay. This is Lucky's Tale. I've been playing around a little bit with it, but definitely like haven't gone too far in. And I plugged in the positional tracker, so yeah, I can get closer to it, further away from it. But what I want to show you guys, and we'll do something I haven't done, because I think this really shows off some of the things I want to talk about. So so Lucky's Tale is like one of those games where yeah, okay, cool. Where it's a 3D platformer, so I'm just kind of following him around. Oops. As I move him with the gamepad here. And in this specific game mode, we're basically trying to find all these red coins. And so the thing I want to notice here is, and this is I think a great use of VR as compared to like a flat screen. And there's a huge difference between this versus just like the actual gameplay. So the actual gameplay, like you're just trying to complete the level, as opposed to like finding all these red coins. But like the really neat puzzle part of this here is because with the positional tracking, I can like look in corners, so like I can look around there and it's like, oh wait, there's a red coin here, and it makes really good use of me as a player getting involved with the game. In like a traditional, in the traditional model of like the game, and where you're just like looking at a screen, I don't have that flexibility. I can't like peer around corners, get in super close, and like look around and see, oh, did I actually miss a red coin anywhere? And I think that's a really cool part of this game, especially in this mode. I don't seem to like use it in the story mode that often. Maybe that'll change in other versions of it, but that's something I really liked about what they did here. It's like a really, I think a really good feature. I don't remember this. Whoa! I did not even know that existed. That's really cool. Let's see. Okay, so there's a red coin up there. You can see one. Oh wow! I'm pointing. You guys don't have the depth perception that I do. That's really cool. But I'm gonna go double check here, make sure I don't. Okay, that is one thing that is kind of funny about this though. It's like I start looking somewhere, and I lose track of where Lucky is. So actually, I'm gonna go do something here, and then so the reason I got myself hit was I wanted people to look at the UI for that. So, and this is actually something you really got to consider when you're building VR games, is where do you show 2D information like lives, like score, any of that, because you don't, unlike in traditional gameplay, you don't have a HUD that is like consistently there. You don't really want a HUD. Because like a HUD in general will make people get sick, and that's something that's very different about VR as opposed to PC gaming or console gaming. Okay, I'm gonna grab that coin, and like so, if you took a look there, so they don't tell you at any point. They'll never tell you that like, oh, I still have to get X number of coins left. They'll only tell you that once you actually find it. And like the reason for that is because you don't have a HUD, so they can only offer that information to you at that point. And honestly, like as far as UI is concerned, you do have a couple of options. Like Lucky's Tale chooses to like only provide the information when it's relevant to you. But you can, for example, one thing they could have done is like maybe if I'm looking up in the sky, and I did this pointing thing again. But maybe if I'm looking up in the sky, I can find out all the information I want. Oh, and I'm dead. All right. So if I like say for example looked up there, it's like maybe you could have all of the information displayed about like how many lives do I have, how many, what's my score, like how close am I to finishing the level. That's all a possibility, but like it's again something you really have to think about when you're designing stuff. And so the reason I want to bring that up in particular is when we're talking about this elephant cardboard game that we're developing. Oh, and totally missed that there. Let's see. This is the really cool start about positional tracking. But if we're talking about UI, we really need to think about like how do we tell the user how many, like if we're thinking maybe it's going to be level based, or if we're going to think, oops, I totally messed that up. I'm pretty sure that yeah, there's a red coin up there. If we're thinking about how we're going to tell the user how many lives they have and like how much food they've missed and like what their score is, we need to display that in the 3D world, and not as like a always stuck to my head, because that'll get people sick really fast. Wow, okay, I totally missed that. So yeah, I'm gonna see how far I can get on this life. And then probably we're gonna end the stream there. Then let's see. Oh, there's my life. Alright, I'm gonna take this off. But like those are the really some of the big things that I wanted to highlight. As far as like Lucky's Tale is concerned. And it'll be super helpful. Like playing around with what other people have tried in VR is super helpful for learning about your own design principles and like what you think. Because these are people who have been experimenting with VR for a long time, so it's useful to really try what they've learned and see how it works in your own development. And of course, experimenting what they've done, seeing where their pitfalls are. Will help you think of like better ways to actually like create good experiences. So yeah, so that's some of the stuff I want to highlight with Lucky's Tale. If I'm gonna leave the stream running for probably 30 more seconds just to see if there are any follow-up questions. But other than that, like let me know like if this is something you want to see, if you want me to change things in the way I do things. Looking for feedback because I want to give the best possible experience for you guys. Like make it actually worth your time to come sit down for what was this, about 2 hours today, on a weekday, learn some cool stuff, help create this cool game, interact with everyone. And I realize that YouTube chat is probably not the greatest way to go about this. We're actually trying to create a website right now to actually streamline this process a bit more, to not only engage with me, but to engage with everyone else as well. So, yeah, I'll just let this running for some more time. I'm going to start packing up a little bit. Yeah, thanks guys, appreciate it. And yeah, we'll be back next week. Oh yeah, I guess like our if you want to keep following up with this, like our Facebook page or subscribe, and then you'll get a notification the next time we do it. It's gonna be sometime next weekend. Might be the same time, although I do want to experiment a little bit to see what times work best for people on the weekends. We decided on 10 a.m. Today because actually Abdo is based in Algeria, so the morning for him actually works pretty well. But yeah, let me know. Yeah, just we'll keep you updated on like what times we decide. We might put a poll out. I think we're trying to set up a mailing list also in case you want email notifications also. But yeah, with that. Oh, I need to actually put my mouse back in. I think I'm gonna go ahead and wrap this up. I think the chat stays open a little bit more longer. I'll be monitoring that if it does. If not, feel free to leave a comment below and then get back to you as soon as I can. But yeah, I will catch you guys next time. It's been Fuseman. I'm logging out.